Hi guys, welcome to our last lesson video. Alright, so in this last week, last thing we're going to talk about is this thing called Law of Cosines. And it goes hand in hand with Law of Sines. So it's another set of formulas that helps you solve for missing sides and missing angles in non-right triangles. So once again, this week we're working with non-right triangles. And the Law of Cosines is as follows. So once again, we've got triangle A, B, C. Remember, angles are capital, side lengths are lowercase, A, B, C. They match across from each other. So, angle B goes with side B because the angle is across from the side A and C. So law of cosines, technically there's three formulas, but it's all the same formula. It's just the letters are switched around. So let's say, for example, that I need to know information either about side A or angle A. Well, the law of cosines formula would be A squared equals B squared plus C squared minus 2BC cosine of A. So this is the formula for law of cosines. And so if you wanted to solve for side length A or angle A, this is the formula you would use. And then you can change it up. So this would be side, and this would be angle. And then you can change it up for B squared and C squared, but I use different letters anyways. So whatever one you're looking for, this is the side length or that you're looking for, so you plug in everything for B and C and the angle, or if you're missing the angle and the side, one of the two. But I'll give you guys the other ones as well. You could write it as B squared equals A squared plus C squared minus 2AC cosine B, or you could write it as C squared equals A squared plus B squared minus 2AB cosine capital C. So these are the three variations. So if you can tell, angle and side go together, angle side, angle side. That's the trick. So if you're working with one side, then you plug in the other two sides squared minus 2 other side times cosine of the angle that matches the side you're looking for. So this is law of cosines, and we're going to solve for all the sides and angles of a given triangle. So we're actually only going to use law of cosines once, and then we are going to go back and work with some law of sines stuff. So step 1 for these problems is solve for a missing side using law of cosines, and then step 2, use law of sines for all other missing info. You guys will see that law of cosines, you can tell just by the formulas, is a little bit more work than last week's law of sine stuff. The problem is we can't use law of sines for these problems easily. So law of cosines helps out a little bit more. So this is the side angle side situation of a triangle. The problem is there's no pair. So we can't use law of sines. So if you're wondering why we can't just use law of sines for your problem, why do we have to use this thing? Because remember, for law of sines to work, you have to have a pair of information. So whenever you don't have a pair of information given, you have to use law of cosines so that you can make a pair. So solve for missing side using law of cosines to make pair. Because you have to have that pair of information to be able to use law of sines, which is easier. So if you look at this first example here, there's no pair. There's no angle and side that we know the information for. We don't know angle A, but we know side 7. We don't know angle C, but we know side 5. And then we know angle B, but not side B. So there's no pair. So and then there's no way to find the two missing angles using 180 either. So we can't use law of sines. So that means we have to start by finding law of cosines. And the reason for that is if we find side B here, then we have a pair. So the first thing we're going to do is try to find side B. And so we're going to use the B version because we want to know B. Now if you notice, B is actually squared. So the last step is we're going to be taking a square root. So let's plug in because we don't know B. So B squared equals A squared. A is 7 plus C squared, which is 5, Remember, I know that because it's across from each other. So side A is 7 because it's across from the angle name. Side C is 5 because that's across from the angle name. Minus 2 times A times C times cosine of the angle B. So 2 times side A would be 7. Side C is 5. And then cosine of the angle for B, which is 100. And so literally all we do, this is all one number. And so I'm going to recommend that you guys use Desmo Scientific. It's just harder for me to make videos using Desmo, so I'm going to use my calculator. But I'm just going to type this whole thing in, and we're going to get some decimal. So 7 squared plus 5 squared minus 2 times 7 times 5 times cosine of 100. And I get 86.155. So b squared equals 86.155. And then your last step, and this is something that people often forget, b isn't by itself. We have to take the square root. So b equals the square root of 86.155, which is 9.282. So side length B here is 9.282. All right, so we just found this missing side length. So in terms of solving for all the pieces of the triangle, I know all 3 side lengths now, and now I'm just missing these 2 angles. And so step 1 is always just, use law of cosines to find a missing side. But now we have a pair, and so then we're going to use that pair and use law of sines to find the missing angles. Because trust me, law of sines is a lot easier to find angles than using law of cosines. Because if you use law of cosines, you can use law of cosines to find missing angles, but you have to get this part by itself, and it's not nice. It's messy. So now let's switch over to law of sines. Our pair is sine 100 over 9.282 equals, doesn't matter which angle we solve for first. Let's do A. Sine A over 7. So remember, turn this into a decimal. Sine 100 divided by 9.282. 0.106. 0.106 equals sine A over 7. Multiply both sides by 7. 7 times 0.106 is 0.742. So I'm going to come up here. 0.742 equals sine A. To get rid of sine, remember you don't divide by sine. The opposite of sine is sine inverse. So take the sine inverse of both sides. So then the sine inverse, which like I said, it's easier on Desmo Scientific, but the sine inverse 0.742 is 47.902 degrees is angle A. So angle A here is 47.902 degrees. And then last step, to find angle C. To find angle C, we know 2 out of the 3 angles now, so just do 180 minus 100 minus 47.902, which is 180 minus 100 minus 47.902, 32.098. So this one is 32.098 degrees. And we're done. So just to recap, so the first thing we do with these law of cosines problems is, find that missing side so you can make a pair. And then once you have your pair, you can use law of sines to find a missing angle. And then that third missing angle, could we use law of sines? Sure. Could we use law of cosines? Sure. But the easiest thing to do is 180 minus these 2. And so that's the pattern we'll do for all these. So let's try another example. So this is triangle DEF. So, the lettering's different. Triangles can be named with any letters. Typically, law of cosines is always given an A, B, and C because that's the most basic, But it doesn't matter what the letters are. So just to recap, we can't use law of sines because we don't have a pair. We know this angle, but not the side. Side, no angle, side, no angle. So that means first up, we have to find law of sines, use law of cosines. Oh my gosh. We have to use law of cosines to find side E here so that we can make a pair. So to find side E, E squared equals the other two sides. So these are like our a and b or whatever. So 10 squared plus 11 squared minus 2 times 10 times 11 cosine of 108. 108 because that's the angle. All right, and then like I said, you just type this whole thing in and get the decimal. So 10 squared plus 11 squared minus 2 times 10 times 11 times cosine of 108. 288.984. That's e squared. And so the last step to find the side length, take the square root of both sides. So e equals the square root of 288.984. 16.999. I'm just going to round that up to 17. That's like super close. And because we rounded, it's probably supposed to be 17. So I'm going to call E 17. All right. So now we have our pair. And so now we can do law of sines. So law of sines says, use this pair to find the two missing angle or one of the two missing angles. It doesn't matter which one. Let's go with D. So first write your pair. So sine 108 over 17 is equal to angle D, sure, over 10. So find this decimal. Sine 108 divided by 17. No, I didn't divide. Sine 108 divided by 17 is 0.056 equals sine D over 10. Remember, we're trying to get D by itself. Got to multiply both sides by 10. 0.056 times 10 moves the decimal point over 1, so it's 0.56. So we'll go up here. 0.56 equals sine D. And remember, to get rid of sine, you take sine inverse of both sides. Cancels out. The sine inverse of 0.56 is 34.056 degrees is D. So this angle up here is 34.056 degrees. So all that's left is this last angle. So remember, the easiest thing to do to find this is just 180 minus 108 minus 34.056, which is 180 minus 108 minus 34.056, 37.944 degrees. So this is law of cosines. So really, law of cosines is all about use law of cosines, find a pair, and then use law of sines, because law of sines is a little bit easier. So if you're wondering why I took a week on law of sines, I wanted you guys to get good at law of sines, so that way when we got here, law of sines wasn't as scary to use. So we really only ever have to do one step with law of cosines. As soon as we make a pair, then we can move on to law of sines. It's a little bit easier. So once again, these are the level 2 questions this week. The level 3 questions are the word problems where you have to make a picture and solve for some missing information. So to estimate the length of a lake, Caleb starts at one end of a lake and walks 95 meters. He then turns and walks on a new path, which is 120 degrees to the direction he was walking first. And walks 87 meters more until he arrives at the other end of the lake. So the way this is working is there's a lake. I don't know. I'm just going to draw an oval. There's a lake. And so he wants to know how long it is. So from here to here, what's the length of the lake? So what he does is he walks like that. So the first length is 95 meters. And then he turns 120 degrees, which this is not an accurate picture. So this is 120 degrees. And then walks back, and this length is 87 meters. And so we want to know what's the length of the lake. Well, this is the same. This looks almost exactly like this triangle, right? We have side, angle, side. We can't make a pair, so we have to use law of cosines. So the helpful thing is, the first step is we usually make a pair. And so that first step is actually going to tell us this side length that we need to know, because the first step is always to find that last missing side length. And then we're going to be done. Like, we don't even need to do law of sines because we're looking for this length, and then we'll be done. So Law of cosine says, I'll just use x. X squared equals the other two sides squared, 95 squared plus 87 squared, minus 2 times 95 times 87 cosine 120. So this is going to be a big number because, you know, these are big numbers. That's okay. Lakes are large. 95 squared plus 87 squared minus 2 times 95 times 87 times cosine of 120. Yeah, that's a large number. So x squared equals 24859. And then our last step, square root both sides. Second square root of 24859 is 157.667 meters. And we're done because that tells us this side length, 157.667 meters. And that's what we wanted to know. So this would be the length of the lake. So if you guys are really interested, you know, you could go to like Lacamas Lake and walk in a triangle to find how wide the lake is. All right, and then I have one more example for you guys. Jack and Jill both start at point A. They walk in a straight line at an angle of 105 degrees to each other. After 45 minutes, Jack has walked 4.5 kilometers. Jill has walked 6 kilometers. What is the angle at Jill? So we want to know the angle that Jill is at. So the angle between the starting point and Jack. So they start at point A. They both walk. So let's call this Jack, Jill. So we know that, so here's starting point A. Jack has walked 4.5. Jill has walked 6. And they're at 105 degrees apart. So once again, you know, side angle side, we want to know this angle. So our final answer that we want is this angle. But we don't have a pair to solve for this angle. So the first step is to make that pair using law of cosines. So we're going to solve for side A first, so that way we can make a pair. And then use that pair to solve for this angle using the side length, using law of cosines. So first up, law of cosines. So A squared is equal to 4.5 squared plus 6 squared minus 2 times 4.5 times 6 cosine of 105. Find this number. 4.5 squared plus 6 squared. Where's my squared? Minus 2 parentheses 4.5 parentheses 6 cosine of 105. 70.226. So last step, square root. So A equals 8.38. Nice. Kilometers. So this is really 8.38. So now we know a pair, and then we can solve for angle of Jill. So the pair is sine 105 over 8.38 equals sine, I'm going to call it, you know, Jill, angle of Jill, over, and across from Jill is 4.5. So let's find sine 105 divided by 8.38, 0.115 equals sine of Jill over 4.5. You know, we're trying to get this by itself, the angle of Jill. So multiply both sides by 4.5. So 4.5 times 0.115 is I'm just going to leave that 0.5175. I usually round 3 places, but we'll keep it accurate. 0.5175. It ended up pretty nice. Equals sine of Jill. When we're trying to get that angle by itself, how do we get rid of sine? We take the sine inverse of both sides. So the sine inverse of 0.5175 is 31.165. So Jill's angle, the angle at Jill here, is 31.165 degrees. And that's your final answer. All right, guys, so this is law of cosines. This is exactly what your quiz is going to look like. 2 level 2 questions just like this. And then 2 level 3 questions just like this. One where you just have to do law of cosines that finds a missing side length, and then one where you have to do law of cosines to find the missing side length, so you have a pair, and then solving for an angle with law of sines. And that's our week this week. Hopefully this goes well.